Alright, number one says graph and state the request information, label your graph. So here you have y equals negative 1 over 8 times x minus 1 squared plus 1. So we have to find the vertex, C, the focus, the directrix, the length of the focal chord, FC, the axis of symmetry, and excuse me, what direction does the graph opens. So if we look at it, remember I gave you that chart where if it's y equals, it either opens up or down. Now, if it's a positive 1 over 8, it'll open up, but in this case, it is a negative 1 over 8, so it opens down. Now, the next thing to find is the vertex. Looking at here, the vertex inside the parenthesis is always the opposite. So if it's a negative 1, x is a positive 1. And then outside, if it's a positive 1, it remains a positive 1. So here the vertex is 1, 1. So let's go ahead and plot that. 1, 1 is right here. That's my vertex, blue. To find C, right? To find C is basically you take the denominator of the fraction and divide it by 4. In this case, it's 8. So 8 divided by 4 is just 2. So your C value here is 2. You have to find the C value before you can find the focus. So now, to find the focus, well, you have to start from the vertex and move C unit, or in this case, 2 units. Now, 2 units in what direction? Well, 2 units down if the graph opens down. So you got to follow this direction. So if the graph opens down, from the vertex, you move 2 units down. And this is the focus. So this here is 1, negative 1. The directrix is the opposite way. So from the vertex, if we went down 2 units to get the focus, from the vertex we go up 2 units to get the directrix. Now the directrix is a line. So it's not a point, but it's a line. So if it's a horizontal line, is y equals, and where does it cross the y-axis? Well, 1, 2, 3, at positive 3. To find the length of the FC is basically just the denominator. Okay, the denominator of the fraction here, which is 8. And the axis of symmetry, well, first we have to graph. So we have to use the length of the FC to find the other 2 points. So starting from the focus, okay, divide 8 in half, which is 4. So at my focus, I'll go 4 to the left, 1, 2, 3, 4. I'll go 4 to the right, 1, 2, 3, 4. Because the focus split the length of the focus in half. So I'll have this now connect these 2 points with my vertex. The graph is opens down, right? That's my graph. Axis of symmetry is this line right here. So it is x equals, what is the x value of the vertex? 1. Number 2 asks us to graph the following quadratic function using transformation. f of x equals 2 times x minus 1 squared minus 2. For this problem, you can really just use the calculator. If you would go to the graph and just put the equation in 2 open parenthesis x minus 1 close parenthesis square minus 2. This is what the graph should look like. And then, as you can see, the domain, well, the graph is pointing up, but it's going all the way to the right. It's pointing up and it's going all the way to the left. So the domain really is from negative infinity to positive infinity. As for the range, graph is pointing up, so it has a minimum value right here. Okay, so it starts right here and it goes all the way up. Well, how do we find this value? You can first solve by getting the vertex. So remember, whatever inside the parenthesis is the opposite. So if this is negative 1, it becomes a positive 1, and outside remains the same. So you get 1 comma negative 2. That's the vertex. So let's graph our vertex, or let's plot our vertex as 1 down 2. So as you can see, this is the point. This is the point where the graph starts, right? The vertex. So it goes from here all the way up. So at negative 2, it goes all the way to infinity. Now it's inclusive, right? Closed circle, inclusive at negative 2. So you put a hard bracket. And that's the range. Axis of symmetry, remember, it splits the graph in half. Right? Remember, if it's y equals, then axis of symmetry is x equals. Now, what's the x value in the vertex? 1. Alright. Now, my graph is not really drawn very accurate here. So let me go ahead and erase it. But that was just the purpose of looking at our range. So now to find the x and y intercept. To find the y-intercept, you can use the calculator. Go to Menu, scroll down to Table, and Split Screen Table. Find where x is 0. Okay, x is 0. When x is 0, that is your y-intercept. So here, the y-intercept is 0, comma 0. Just happens to be that when x is 0, y is also 0. Okay? So it's like that. Now what about the x-intercept? Well, you can exit. So go to Menu, Action. Well, go to Menu, Table, and Remove Table. Okay, now go Menu, Analyze Graph, and select 0. See this dashed line? You can scroll it all the way to the right. Click down once, and then now release and drag. See how when you move over, it shows up a point, 2, 0. That's one of the x-intercept, 2, 0. Right? If you scroll more, another point pop up, 0, 0. That is the other x-intercept. Okay. Now to state the transformation, basically, where did this graph go? Right? How did it move from the standard parent graphs? Well, it moved, right? It went to the right 1 and down 2. It's, since the number here in front is a number greater than 1, so it's a vertical stretch. Alright, the next problem, asks you to simplify each number by using the imaginary number I. Now, we know that we can't take the square roots of a negative number. That's why the imaginary number comes in. So, to remove this negative, all you have to do is just write I outside the parenthesis. All right, that's how you remove the negative. So now, well, what's the square root of 64? Square root of 64 is 8. So now you got I times 8. Or you can rewrite it and put 8I. Number 4, square root of negative 24. So you do the same thing. Instead of negative, to remove the negative, you put I. And then now I times the square root of 24. Now you have to simplify this radical. One way is to use the tree method, or you can just go in the calculator, press menu, 2, which is number, and 3, factor, and put in 24. So it say here is 2 times 2 times 2 times 3. So there are 3 2's. So you have 2 times 2 times 2 times 3. If a number has a pair, it goes outside of the radical. Don't forget about the I. And inside, you still have 2 times 3. Well, let's simplify this. 2I, well, 2 times 3 is 6. So you have 2I times the square root of 6. Number 4, same thing. Since it's a negative, write an I outside. Right, inside is 3. And then, well, you can't really simplify square root of 3 anymore. So this is the answer. For number 5 and 6, you first have to plot each point and find its absolute value using this formula, the absolute value formula for complex number. So number 5 only have 3 i's, right? The number with the I tell you if it goes up or down. So since it's a positive, you go up 1, 2, 3, and that's the point in a complex plane. Now to get the absolute value, well, this is the formula. We don't have a number without an I. So it's just square root of 0 square plus, right? BI, well, is 3 square. And if you simplify, you get 0 times 0 is 0. 3 square, right? 3 times 3 is 9. So what's left is square root of 9, which is 3. Okay, here the number without the I tell you go left or right. Since it's a positive 6, you go 1, 2, 3, 4, 5, 6. And then plus 12i. Obviously, this is going outside the graph. So 1, 2. Well, we can count it by 2. 2, 4, 6, 8, 10. So 2, 4, 6. 2, 4, 6, 8, 10, 12. Right, somewhere up here. And then plug in the formula with square root 6 square plus 12 square. So what's 6 square plus 12 square? Well, 6 square is 36. 12 square is 144. And 36 plus 144 is 180. So now the square root of 180, right, we have to simplify this radical. So once again, menu, 2, 3, 180. So you have 2 times 2 times 3 times 3 times 5. So 2 times 2 times 3 times 3 times 5. Here's one pair, it goes outside of the radical. Here's another pair, it goes outside of the radical. Inside is 5. So 2 times 3 is 6, and inside the radical is 5. Alright, numbers 7 to 10, it asks you to simplify each expression. Complex numbers here, of course. So if it's adding, okay, so it's just combine like terms. 2 plus 4. Sorry, 2 plus 4 is 6. Okay. Now, 4i plus negative I, that's 3i. So you have 6 plus 3i. Number 8. Negative 6 minus negative 1 is negative 7. Negative 7i minus 3i is negative 10i. And that's your answer. Number 9. Since this is multiplication now, you have to FOIL, right? So 8 times 2 is 16. 8 times 7i. Well, what's 8 times 7? It is 56, so you get 56i. I times 2 is 2i. And I times 7i is 7i squared. Combine like terms, you have 16 plus 56i plus 2i is 58i plus 7i squared. We're not done here. Okay, we're not done here because we also know that I squared, right? The key here is I squared is equal to negative 1. So you have to substitute back in where the I squared is. So you have 16 plus 58i plus 7. Instead of multiplying by I squared is negative 1. So now it gives us 16 plus 58i minus 7. Combine like terms. You get 16 minus 7 is 9. So you get 58i plus 9. Okay. Same thing for number 10. This time, this square means that there are two of them. Right? There are two 9 plus 4i. Once again, FOIL. 9 times 9, 81. Right? 9 times 4i, that's 36i. Here, 4i times 9 plus 36i. And 4i times 4i is 16i squared. Okay, combine like terms, you get 81 plus, well, what's 36 plus 36? That's 72i. And we know I squared is negative 1, so plus 16 times negative 1. This becomes 81 plus 72i minus 16. Combine like terms, you get 72i plus 81 minus 16 is 65. Alright, so number 11, it say a projectile is launched with an initial velocity of 98 meters per second. Draw and label a picture. So you all want to start off by drawing a picture. Alright, a picture always help. Now, it's launched, so something is launched up in the air, right? And it's coming back down. And it starts at 0, right? It always starts at 0. So here we're trying to make it like it starts at the origin. And let's write an equation. So if it's in meters per second, we're going to use this equation right here. So we know that h equals negative 4.9 t squared plus v naught or v subscript 0, that's initial velocity. Well, what's the initial velocity here? 98. Then times t, and h naught or h subscript 0 is the initial height. Well, the initial height here is launched from the ground, right? So it's just 0. So this is our equation. Next it asks, will the projectile reach a height of 500 meters? Right? We know that the maximum height has to be, or it has to be right here. And it happens so that this point, at this point, right, is this kind of the same as the axis of symmetry. Okay? And D as when will the projectile hit the ground? That's the total time from here to here. What is the maximum height of the rocket? Right, this is the maximum height. And when does the rocket reach the maximum height? So let's first find the time, the total time that it takes from here, and it launches and it drops down all the way to the ending. So to do that, you go to the calculator, press menu, 3, 3, 1. Okay. Real numbers, degree of 2. Number in front of t squared, negative 4.9. Right? Number in front of t, 98. And the constant is 0. Press OK. So it's 20 seconds. 20 seconds. From here to here, it takes 20 seconds. So when will the projectile hit the ground? 20 seconds. Now, to find the maximum height, we know that if from here to here is 20, and the axis of symmetry splits the parabola in half, well, half of 20 is 10, right? 10 seconds. So it takes from here, 0 to the maximum height, it takes 10 seconds. Okay, so when does the rocket reach the maximum height? 10 seconds. Now, how do we find the maximum height? Well, if we know the time it takes to get to the maximum height, which is 10, we'll just plug 10 in for t to find the maximum height. So you get h equals negative 4.9, 10 squared plus 98 times 10 plus 0. Okay, plus 0. So I'm going to put that in my calculator. Negative 4.9 times 10 squared plus 98 times 10 plus 0. Didn't even need to put the 0. So it goes up to 490. Right, 490 right here. Because at 10, this point is basically 10, comma 490. Right, my x and my y value in a way. So if x is 10, or if the time t is 10, the maximum height is 490. So it reaches up to 490 meters. Okay. So we can go back to C and answer it. It asks, will the projectile reach a height of 500 meters? No. Right? No, it only reached to 490 meters. Alright, number 12 says a rectangular poster has an area of 45-inch square. The length of the poster is 1 inch less than twice its width. Draw a picture. Right? You always want to draw a picture. So here, there's the poster. Now, the area of the poster is 45-inch square. We know area is equal to length times width, right? Length times width. Well, we know the area is 45 inch squared, so 45 equals length times width. Now it says the length of the poster is 1 inch less than twice the width. Twice the width is the same as 2 times W. And 1 inch less is just minus 1. Okay? So how do we find the dimension? Well, if we have the area and we know what L is, we'll just substitute L into this equation. So you get 45 equals 2W, right? Instead of L, I put 2W minus 1 times W. Now, remember, hippity-hoppity, distributed property. Dropping bars, man. But, so, here you go. You get here 45 equals 2W times W is 2W squared. W times negative 1 is negative 1W. And then that's it. That's the equation. Now to solve, let's subtract both sides by 45. So now these cancel out, you get 0, 2W squared minus W minus 45. Okay, now to find the width, well, go to your calculator and basically factor. Remember, menu 331, real number, degree is 2 because it's x squared or W squared. So the number in front of W squared is 2. The number in front of W is negative 1. And the constant is negative 45. Press enter. And you get negative 9 over 2 comma 5. Now we know length and measurements of such thing are positive, right? They're positive numbers. So our W is 5. So once we have our width is 5, well, we know the equation to find length. Just plug it back in, right? Plug W in. So what was it? 2 times W, which is 5 minus 1. So L is 2 times 5 is 10. 10 minus 1 is equal to 9. So our length is 9, our width is 5. Alright, to solve the following inequalities. Okay, to solve the following inequalities, first we have to find what x is or what's the value of x if it's more than 1. Right? So we have to factor. The best way to factor, quickest way, easiest is menu 331 again. The degree is 2, real numbers. Number in front of x squared here is 1 x squared. There are no x, so it's 0, and the constant here is negative 81. Okay, press OK. You end up with negative 9 and 9. So you get that x is equal to negative 9 and x is equal to 9. So next step, let's draw a number line. Okay, let's say here is negative 9. Here is 9. Now, look at the x squared value. If it's a positive, graph is pointing up. And then connect to make a parabola. Say x squared is less than 81. X squared minus 81 is less than 0. This horizontal line, our x-axis, that's what's 0, right? So if it's less than, we shade below. So that means if we shade below, we'll hit this part of the line. So what are these x values? Well, it's just between negative 9 and 9. Number 15. Once again, we got to know what x is. So menu 331, right? Factoring. So number in front of x squared is 1, right? The coefficient in front of x squared, the coefficient in front of x here is 6, and the constant is 9. So you get that x is equal to negative 3 and x is equal to negative 3. So x equals to negative 3, x equals to negative 3. So there's only one value. Same thing, right? Draw the number line and place negative 3. Since it's only one number, it's only one number on the number line. Now, graph here is a positive x squared, so it's pointing up. It says x squared plus 6x plus 9 less than 0. Remember, this horizontal line is 0. So we're shading below. Okay, doesn't hit any part of the line. So here, the answer, no solution. Alright, number 16, there's a typo. This should have been a negative 20 in the first place. So now you have negative 2x squared plus 6x greater than negative 20. To move, we have to move this 20 to the left. So we add 20 to both sides. So you get negative 2x squared plus 6x plus 20 is greater than 0. So now we got to factor this. So go menu 331, and the coefficient in front of x squared is negative 2. The coefficient in front of x is 6, and the constant is 20. So we get that x equals negative 2 and x equals to 5. So x equals negative 2, x equals to 5. Now we draw a number line. Draw a number line. Here's negative 2. Here's 5. So now, since the number in front of x squared is the negative, the graph will be pointing down. Right now, connect to make a U. And now, says that, remember this is our 0 line. So, negative 2x squared plus 6x plus 20 is greater than 0. So we shade above. When we shade above, it is this part of the line. So x is just in between negative 2 and 5. Alright, for this equation we have to bring everything to the left with the x squared. So let's subtract 7x. So you get x squared minus 7x. Alright. These cancel out. And then also bring over the 30. So subtract 30 to both sides. You get x squared minus 7x minus 30 is greater than 0. So now, got a factor. So we have menu 331. Okay. Press OK. Coefficient in front of x squared is 1. The coefficient in front of x is negative 7. And the constant is negative 30. So we get that x is equal to negative 3, comma 10. So x is equal to negative 3 and x is equal to 10. Now let's draw our number line. Here is negative 3, here is 10. It's a positive x squared, so the graph is pointing upward. Right? Connect to make a U or a parabola. Now x is x squared minus 7x minus 30 is greater than 0, so we shade above, right, the 0 line. If we shade above, we hit these two portion of the line. So from here, x is always the line is going all the way to the left, right? So x is less than negative 3. For this part, x right? The line is going all the way to the right, so x is greater than 10. They're open circles, right? They're open circle because of the inequality sign. And those are your answers.